Thanks, Nancy. It's a pleasure to have a chance to come and speak with you all today. So my group's research expertise is really in the area of polymer science, bridging across polymer physics and polymer chemistry. And in talking to a lot of different folks running, for example, major NSF or DOE research centers in this area, people working in industry, particularly folks in polymer science are focused on sustainability, or people working on high throughput and combinatorial research, often focused in biomedical materials. There's really a sense that we're held back by a lack of sharing in polymer science, the inability for our labs to effectively collaborate, to effectively share information, and to effectively organize information so that it's findable, even sometimes, and no one has to admit it, by your next grad student, which is kind of an embarrassing problem that many research groups have. To address this, we've been working to lead a team joint between MIT, Dow, Citrine Informatics, NIST, and I'll give a disclosure statement. Debbie's on our team, and the University of Chicago to work on building something called the Community Resource for Innovation in Polymer Technology. And the idea of this resource, or CRIPT, is to bring together a database with essentially web applications that make an ecosystem that allow people to basically interact, share, and find data. And so a big part of it is kind of software engineering illustrated on this slide of how do you bring together data with the right tools. And then another big part of our team is working on actually fundamental chem informatics tools on how we can better, for example, represent polymer molecules. Chemical structure with line notation in polymer science has traditionally been a very big struggle because polymers don't have deterministic structures. How we can actually build search engines to find this polymer data. Once you have a way to write the structure that's well defined, you'd like to be able to search it. Currently, we just type in things like polyethylene in Google or Web of Science, and it's not very effective. And then we work on graph-based data models as a big collective between all our organizations, trying to figure out ways we can actually organize the data to make it easy to find and actually make it flexible enough to account for what is an extremely diverse field. You want to see all these academic tools then come together into very nice graphical things. And so this is an example of one of the tools that's been built and deployed already online, which allows you to draw chemical structure and actually get line notation for polymers. And this semester, I'm using this in teaching for the first time. And I will say, while my chemistry students are not big fans of line notation, they're huge fans of the software that generates the line notation for them automatically. So it really illustrates the value of these types of user approachable tools in broadening the access to chem informatic data. So what do I think the lab of the future will be? I was asked to give a few slides on that to conclude. And so I think that, we can certainly do lots of valuable research without bigger data, but there's more research we can do when we have bigger data. And so I show here an example of a project that we recently completed where we developed the first quantitative structure property relationship for polymer biodegradability based on the molecular structure of the polymer. And this involved synthesizing a library of about 650 different polyesters and then individually characterizing the biodegradation of each one. This makes it the biggest biodegradation data set that's publicly available by more than an order of magnitude. So this is the type of thing that I think is possible when we start to look at more automation and smarter tools and wider availability of data. And I really think those are the themes that we want to touch on, is that the labs of the future will have more automation. This will increase the productivity of the researcher. I don't see tools that will eliminate the researcher in the near future. I think the cost-benefit analysis and creativity there, to me at least, doesn't make sense yet. But there's a lot of productivity enhancing tools. And then
1 minute, please.
The way we integrate theory, simulation, computation as part of everyday workflows, I think is something that's very important in the future. Often experimentalists traditionally have not integrated this well into their workflows. And so I think that tools that help us to do, for example, predictive design of molecules before we synthesize them, and having this as part of your daily workflow. You start with the compute, then you order chemicals, is something that's very powerful for the future. So that was my last slide. So thank you very much.